Next, we will work to find solutions to polynomials with complex zeros. So to start with, we'll just do quadratics where the degree is 2. So we'll use the quadratic formula. So first we need to have it in standard form, set equal to 0. So we subtract 5z from both sides. For example, 4a, we'll have 3z squared minus 5z plus 10. I just moved the z in the middle there, so it would be in standard form. So now our a is 3, our b is -5, and our c is 10. So then quadratic formula, just as a reminder, x equals -b plus or minus square root of b squared minus 4ac all over 2a. If I was in class with you, I'd sing the song, but I feel silly doing that on a video. So now to solve, x equals -b, so the opposite of b, opposite of -5 is 5, plus or minus the square root of b squared, so -5 squared, which is 25, minus 4 times 3, which is a, times 10, which is c, all over 2 times 3, which is 5 plus or minus 25 minus 4 times 3 times 10, which is 120. 25 minus 120 is -95, and that's all over 6. Kind of keep simplifying for a little bit. So 5 plus or minus square root of -1 times square root of 95 over 6, which is 5 plus or minus the square root of 95i over 6. And now we can just split it, Hart method essentially, because 95 does not, you can't take any perfect squares out of it, so you can't simplify the radical. So we get 5/6 plus or minus square root of 95 over 6i, which is lovely. It's kind of bizarre to picture right now because it's a non-real number, but don't worry about that yet. For now, just focus on the mechanics and getting your answer. Example 4b, it's already in standard form, so we're good there. So x equals the opposite of -2, which is 2, plus or minus the square root of b squared, so -2 squared, which is 4, minus 4 times 1 times 7, all over 2 times 1, which is 2 plus or minus the square root of 4 minus 4 times 1, which is, times 7, which is -4 minus 28, over 2, which is 2 plus or minus square root of -24 over 2. And as always, you can skip some of these steps, but I like to give you most of them when I'm showing you examples. 2 plus or minus square root of -1 times square root of 24 over 2. 2 plus or minus square root of 24i over 2. 24 looks like we can take some perfect squares out of it. You can do it in your head, great. Otherwise, I'm going to go over here and split it. So 24 splits into 6 and 4, and you'll get the same answer even if you start out with 8 and 3 or 12 and 2. So it looks like 6 then can go to 3 and 2. No perfect squares there, but 4 is 1. So I'm going to split this into 2 plus or minus square root of 6, because we can't take any perfect squares out, square root of 4 I over 2. We're almost there. Square root of 4 is 2, so we have 2 plus or minus 2 root 6 I over 2. Really close. Almost there. Hart method, 2 over 2 is 1. Plus or minus, well, 2 over 2 is still 1, so those will actually cancel. So 2 root 6 over 2 is just root 6 times I. So it simplifies down pretty nicely. And I add a couple examples in here where we factor a binomial. There's examples like this in your homework. So we're essentially using the theorem that we had before that we talked about, which said that a plus bi times a minus bi equals a squared plus b squared. So this is where this is coming from. Okay, so for our first example, let's look at x squared plus 25. So first we want to rewrite this and see if we can rewrite it using a squared plus b squared. So let's do x squared plus, well, 5 squared is 25. And since it's a squared plus b squared, we're not going to worry about the negative 5 piece. X squared plus 5 squared. So that means this can factor into, so this is our x is our a, 5 is our b, so we can rewrite this as x plus 5i times x minus 5i. Kind of weird. But yeah, if you multiply this through, you'll just get x squared plus 25. So that's what that theorem does for us. For another one, let's do 6a squared plus 24. So if we want it to look like a squared plus b squared, we're going to have to pull something out. Basically try to just get rid of that 6. So fortunately, we can take a 6 out of both of these terms. So 6 times a squared plus 4, because 6 times a squared is 6a squared. 6 times 4 is 24. So now the 6 will just tag along. Won't worry about it till the end. So a squared, we can change 4 to 2 squared. So our a is just, well, a, and our b is just 2. So this will simplify into, or factor rather, into 6 times a plus 2i times a minus 2i. Okay, that is it for the 7-5 notes. For the homework, skip number 11 and number 16 because we haven't covered that stuff yet. The rest of it should be fine. Work through it, spend some time, talk through it with people around you, and you know me, try to have some fun. Because math is fun, right? All right, thanks guys.